So hello students, so today we will try to solve this problem of electrostatics. This is from the chapter electric field and charges. So let us read what is the question and we will try to solve it. तो हम देखते हैं ये कौन सा चैप्टर है, इलेक्ट्रोस्टैटिक्स है और इसमें क्वेश्चन जो है वो हम पढ़ के देखते हैं क्या है. क्वेश्चन है अ पार्टिकल ए हैविंग अ चार्ज ऑफ 2 microcoulomb, 2 into 10 to the power minus 6 coulomb is held fixed on a horizontal table. A second charged particle of mass 80 grams. So you can see that what data is given. So what is the data given? So you underline it. So mass of particle is 80 grams. Stay in equilibrium. So what is equilibrium? We will also discuss it. Equilibrium on the table at a distance of 10 centimeter, at a distance of 10 centimeter from the first charge. First charge is this is the first charge and this is the second charge. This is second charge. 80 gram charge is second charge. The coefficient of friction between the table and this second particle is 0.2. Mu is given 0.2. So what we have to find? We have to find the range within which the charge of this second particle lie. आपको एक पार्टिकल पहले से गिवन है, जो ए पार्टिकल है, जो टेबल पर पहले से ही फिक्स्ड है, इट इज नॉट मूविंग एंड इट्स चार्ज इज ऑल्सो गिवन एंड इट्स चार्ज इज 2 microcoulombs. So let us see by using some diagram. Okay, suppose this is a table. Table can be of any shape. I am taking rectangular table. Suppose here a charge is fixed at this point A, okay, and this charge is 2 microcoulombs. Solution: 1 microcoulomb means 10 to the power minus 6 coulombs. 1 microcoulomb का मतलब होता है 10 की पावर minus 6 coulomb. So 2 microcoulomb means 2 multiplied by 10 to the power minus 6 coulombs. इसको हमने इस टेबल पर फिक्स किया हुआ है. दिस इज फिक्स्ड. ये यहां से मूव नहीं कर सकता. दिस इज फिक्स्ड. each and every detail must be written before solving the problem. Each and every data should be written and observed very carefully. Okay. Now this table is not frictionless. This table is not frictionless. It has some coefficient of friction which is given mu is equal to 0.2. And at some distance, suppose it is given, distance is given. Distance is 10 centimeter. At a distance of 10 centimeter, some other charged particle, we don't know its charge, either plus or minus, only q, and its mass is given. Its mass is 80 grams. Okay, its mass is 80 grams. 80 grams is its mass and it is kept at a distance of 10 cm. 10 सेंटीमीटर की दूरी पर एक दूसरा चार्ज रखा हुआ है q. पहला चार्ज फिक्स है जिसका कि चार्ज 2 माइक्रोकूलम है और दूसरा चार्ज है q जिसका हमें पता नहीं है कि प्लस है या माइनस है. तो अभी हमें ये गिवन है कि हमें फाइंड क्या करना है. फाइंड द रेंज विद इन विच द चार्ज ऑफ दिस सेकंड पार्टिकल लाई. सो व्हाट इज द वैल्यू ऑफ दिस चार्ज, व्हाट आर इट्स रेंज. q1 q2 इज सपोज इट्स रेंज. किस रेंज के बीच में ये चार्ज लाई करेगा वो हमें देखना है, जिससे कि ये पूरा सिस्टम इक्विलिब्रियम में हो. इक्विलिब्रियम मींस दैट नेट फोर्स एक्टिंग ऑन दिस q चार्ज मस्ट बी 0 so that it is also not moving. Now suppose case 1, suppose I am taking it as a positive charge. Suppose अगर हमने माना कि q पॉजिटिव है, q is positive, and the charge at A is also positive, so there will be a repulsive force. So now I am representing this electrostatic force as Fe. Okay, it is there is a repulsion, so there must be some other force which must balance this force Fe. इस फोर्स को बैलेंस करने के लिए एक और फोर्स हमें चाहिए जिससे कि ये इक्विलिब्रियम में आए। इक्विलिब्रियम में कब आएगा? जब इसके अगेंस्ट में, इसके अपोजिट डायरेक्शन में कोई फोर्स वर्क करना चाहिए और वो हमें गिवन है क्वेश्चन में, वो फ्रिक्शन फोर्स होगा। तो हम मानते हैं कि इसके अपोजिट डायरेक्शन में जो फ्रिक्शन फोर्स होगा, बिकॉज फ्रिक्शन इज द फोर्स विच अपोज द मोशन, ये पार्टिकल इधर जाना चाहेगा, फ्रिक्शन इसे रोकना चाहेगा। सो फ्रिक्शन विल बी इन अपोजिट डायरेक्शन टू द टेंडिंग मोशन। ओके, टेंडिंग मोशन. Tending motion means if a particle is tending to move towards right, then the friction will oppose it in the opposites motion. So now, in the case of equilibrium, both these electrostatic force and frictional force will be equal. So see, Fe will be equal to this frictional force F. So this is our condition of equilibrium. Now we know that what is the value of Fe, electrostatic force. By Coulomb's law we can find it easily. So it is K. K is the electrostatic constant, or 1 upon 4 pi epsilon naught Q1 Q2 by R squares. So K and Q1 is what? 2 multiplied by 10 to the power minus 6, and Q2 is this unknown charge Q divided by distance between them is 10 centimeter, which I can write 0.1 square. So this is the electrostatic force. Okay, we can simplify it more. We can write the value of K as 9 into 10 to the power 9. K की वैल्यू क्या होती है? 9 multiplied by 10 to the power 9. So after solving, let us see what happens here. Okay, so I think we have to, for the space we have to rub the upper part. I think you have written the question. Okay, so you can write the question by easily. Now we will solve it. So now we will solve it. Equilibrium means that the net force acting on the charge is 0, equal and opposite charge. So now see, Fe is K, so now let us simplify it. So Fe will be equal to, electrostatic force will be 9 multiplied by 10 to the power 9 multiplied by 2 multiplied by 10 to the power minus 6 Q divided by 0.1 square, 0.1 multiplied by 0.1. So if I remove the decimals, then multiply by 10 to the power 2, and you can easily calculate it. So 9 to the 18 multiplied by 10 to the power 9 and 2 is 11, 11 minus 6 is 5. This is the electrostatic force, Newton. So this is suppose second equation, you can say. So this is the force we have calculated, the electrostatic force. This must be equal to the frictional force. This force must be equal to the frictional force. And we know that what is the frictional force? It is equal to mu n. Okay, mu is n. And what is n? N is the normal reaction, which is equal to mg. So frictional force acting is mu mg. And now we substitute the values. Mu is 0.2, mass is 80 grams, so you have to convert to kg. So multiply by 10 to the power minus 3 and multiply it by 9.8. Okay, so after calculation, what we get? So you can see that it is 16 multiplied by 9.8. So 16 8 is 128, 12, 144 and 12 is 156, I think. 156 So it is 16 multiplied 156.8 multiplied by 10 to the power minus 3. So if I write it in decimals only, then it is 0.1568. So this is the frictional force. Third. Now we have calculated. Okay, here Q is also there. Q is also there, multiplied by Q. 18 into 10 to the power 5 multiplied by Q. Here, this is first. Now we will put both the values Fe and F in first, and now we can see that we can easily calculate the value of Q. So let us see now here in this space we can use it for further calculation. So 18 into 10 to the power 5 Q, it is equal to 0.1568. Okay. So Q will be equal to 0.1568 divided by 18 into 10 to the power 5. Okay, so if I now by using, you can also calculate by using calculator. So 10 to the power 5 means, okay, so it is if I see that it is now, if I divide 0.1568 by 18, so we can use a calculator here. So 0.1568 divided by 18, it is equal to 0.00871. 0.00871 multiplied by 10 to the power minus 5. So you can convert it to scientific notation also. So you see, if I shift the points three places, so it is 8.71, and now you have shifted 3 decimals, so you have to subtract 3 decimal here, so minus 8 coulombs. So this is the value of Q 8.71 multiplied by 10 to the power minus 8. So this is the one part of the question, that what must be the charge of the particle so that the whole system is in equilibrium. But you have to see that in the question we have to find the range, in which range this charge should be. So see, for equilibrium the charge Q we have assumed is positive. It can also be a negative charge also. So if it is negative, then what would happen to these forces? Only the difference will be that these directions will be interchanged. Suppose it is negative charge, then the electrostatic force will be towards this fixed charge Fe, and the friction will be in the opposite direction. Only this situation will just interchange if it is negative charge. If Q is negative, then the diagram will be like this, but the value will be same. So what would be the range of the charge so that this is in equilibrium? So we have to only put the plus minus sign in front of this value of Q. In this range, this Q will be in equilibrium. It will not move. So this is the final answer. So for range, you can see that Q lies between negative of 8.71 into 10 to the power minus 8 to 8.71 into 10 to the power minus 8, positive and negative. Okay, you can also put a equal sign here. So this is the range, minus 8.71 into 10 to the power minus 8 to plus 8.71 into 10 to the power minus 8. So I think you understood this problem, and for other problems we will discuss one by one. Thank you.